Appreciate your letting me share a little bit of my DevOps journey here. It's been an interesting couple of years. Okay, a little bit about me. I'm Harris Kirk. I work at Wolters Kluwer. I'm an analytical chemist by education. When I was in graduate school, I realized that software was way more fun than doing chemistry. So after getting my degree, I got out, and I've been working with Java for about 22 years, way back at 1.0.2. Anybody remember Java 1.0.2? Nobody. OK, yeah, I didn't think so. Almost 10 years with Jenkins, release engineering, and DevOps. So Wolters Kluwer is a global company. It is a provider of information software and services that help tax, legal, finance, and healthcare professionals make the most accurate decisions. We have about 20,000 employees, and we're headquartered in the Netherlands. I work in the healthcare division, which provides trusted technology and clinical content to improve patient care and clinical effectiveness. Our primary users of our software are doctors, nurses, pharmacists, and allied health professionals. So let's get to why we're here. So I'm going to talk about the Jenkins challenges we faced. There are about 600 jobs manually maintained via the user interface. We had a lack of version control, both the scripts and the job configuration, lack of consistency of jobs. Nothing new here, right? This is old hat. Anti-agility was what it was. So let's talk about why we do continuous delivery. Why do we do continuous delivery? I'm not going to run through all these, but these are very well known. Automate everything, version control everything, build in quality, done means released. Everyone is responsible, okay? Very traditional, very known items in the DevOps space. What I want to talk about here in this brief talk is about how we can eat our own dog food, meaning we promote these concepts to others that are developing software. But we, as DevOps creators, can do the same thing. We can implement these CD practices. And I want to talk about, in particular, a Java application that I and some others have written to create Jenkins jobs automatically, but it itself is a CD application that is released continuously. How many people have worked with Job DSL in Jenkins? Just a few. OK, quite a few. But for those that don't, it is a way in code of creating a Jenkins job so that you don't go to the UI and click configure and enter the information. Don't do that. You do it with Job DSL. So that's what Job DSL is about. So here's just a simple example of the code. There's a pipeline code, but you see that the pipeline script is embedded in another body of code. So the application I want to talk to you about called Taps is a way of, it's code that creates other code. A C job. A C job is a single Jenkins pipeline job that uses Job DSL to create many folders, views, job configurations, and pipeline scripts. That's what a C job is. The automated pipeline system, otherwise known as Taps, is a Java application that runs as a C job. All over 700 jobs are created via Taps, but not the user interface. We don't use the interface at all to create jobs. The key thing I want to talk to you about today is about how Taps has framework applications that perform continuous delivery functions, and hope to invite you in your own environments to do the same thing. So I'm going to talk briefly about what Taps does in our environment, but again, what I want you to take away is not what Taps does specifically, it's the concept, it's the approach. So when Taps runs, and it runs hourly, it pulls from Git Bitbucket the needed jobs. It creates the jobs, and here are just some minor examples of the jobs that it creates in the UI. And it does that every hour. So let's go over some of the framework, the CD framework features. There are unit tests, just like we tell everyone to write unit tests, right? Java applications, any application should have unit tests. So does Taps. Integration tests. For example, a parse of the Kubernetes build config files is part of Taps. Job cron syntax. All the jobs that get created, they all have cron syntax, right? And all of that is checked. All of that syntax is checked. The pipelines themselves that are created by taps are run through a parser. It's amazing how many errors are just simply due to missing braces, parentheses, etc. So no more entering a job in the entering the job in the UI, clicking run, and finding out it breaks. So you know that ahead of time. More framework features. When taps runs on a Jenkins test instance, all the jobs are configured to do test-like things. For example, the artifacts built don't go to the production Nexus repository, they go to a test repository. Tags that are created don't get pushed back. All those things happen on the Jenkins test environment. On the prod environment, the jobs are configured to run for real in production. And again, I mean Jenkins production. We have Jenkins production and Jenkins test. There's also code to verify that the jobs actually got created on the Jenkins machine after taps runs. It's all about heavy use of testing everything that could possibly go wrong. Continuous delivery. Merges to master are picked up, tested, and released automatically. We don't develop on feature branches, with rare exceptions, extremely rare. Everything is released to master immediately. Finally, we also selected jobs are actually run. Representative jobs are actually run on the Jenkins test instance to be sure that they finish. Again, the test jobs on the test instance are non-destructive, so they can be run as often as you want. Schedules of all the jobs are simply a one line in the configuration of the application, set to true or false. All the job schedules can be turned on or off. We have found running our cloud-based solution on our CJOC, having all the credentials, roles, permissions, keys, and so on, extremely helpful. So as things get rolled from test into production, we can use the same credentials, same credential mechanism. So quickly going through code. When I started out, it was a simple enumeration of what the Bitbucket repositories are. It started out as a list. And then we added what type of jobs do we want to lay down. We want the jobs to be created with a certain JUnit path. Certain people get emails. So this enum is actually fairly large at this point, ripe for refactoring, right? So that will come, all in good time. So job definition. All of the jobs are in a simple, plain, ordinary Java object. Things like whether it gets built on a schedule, what the schedule is, the description of the job, and of course the pipeline script itself are all held in a job definition. Closure creations are part of Groovy. So even though I say it's a Java application, it's really a Groovy application. But here's an example about how the cron syntax is used to create the closures that are passed into the Job DSL. What I'm trying to show you is how simple the code can be to actually do this continuous delivery of a Job DSL application. This is 90% of the code to create a job. Then a job list, right here, the list of all the plain ordinary Java objects with all the job definitions is just iterated and, excuse me, passed into the pipeline job method. So this code right here creates all the Jenkins jobs. Those few lines are what create the Jenkins jobs. All of the code is really also configuration. I don't make any distinguishment between configuration and code. Why is that? Well, the better question is, why were they ever separated? They were separated because nobody wanted to touch the code. Why didn't anybody want to touch the code? Because they were afraid to break it. But if you've got lots and lots of tests in place, none of us are afraid to touch the code. We have so many tests in place where everybody feels free to modify it. So here is an example on a developer laptop, and here's where the really power comes in. We can develop code, develop jobs on our laptop. We don't have to be on Jenkins even. Not even Jenkins. We can do a whole lot right within Gradle. So the application is built within Gradle. Then it runs out to Bitbucket and pulls out all kinds of information. It does a lot of tests, the folder structure. Performs a lot of the tests of the cron syntax and so on, and lays them down into the Gradle build folder. Any Gradle users out here? A few, okay. So the point is that within your IDE or your editor, you can create all these Jenkins jobs. You can see the output of it. All the scripts are laid down right within your editor. So you get high confidence that what you're about to lay down on your Jenkins machine does what you expect. And the idea is that you're continuous and collaborative. Everything is done through pull requests. So all changes to the pipeline scripts, all changes to cron schedules, any conceivable thing to create these jobs is changed through pull requests. And that's what we're striving for. Humans interact through pull requests. Machines kind of interact without our knowledge. I love the example that Victor Farsek has about machines are under the water, humans are above the water, interacting through Git. Refactoring happens a lot, and that's good. We can create a single file of all pipelines and then diff the before and after. All 750 jobs are laid out in a file, compare them before and after. So we can do a lot of refactoring. Okay, so here is the most important slide of the whole talk. So every commit to master triggers unit tests, integration tests, parse of all the pipelines, creates all the jobs on the Jenkins test instance. If all the tests pass, it's released. And everything is laid down to prod. Continuous delivery. Continuous delivery of an application that creates Jenkins jobs. So we eat our own dog food. It's all infrastructure is code. All of the Jenkins infrastructure is code. Easy to add new jobs, easy to add new job types. Everything is under version control. And many people have evolved taps. If you're interested in rolling your own, automate the release process early. Incremental changes, little changes at a time that are fully tested and pushed out. Small changes. Socialize the code. Get other people involved. If they want you to do something, send them a link to the code and say, please modify this. Submit a pull request. Refactor, test. So in summary, it's a pipeline of Jenkins pipelines that supports our business in a constantly evolving manner. Just a shout out to Michael LaPasada, an intern that we hired to do a whole lot of our work for us. And he's taken the ball and run with it. So people love to code. Developers love to code. They don't like to click on UIs. That's it. Thanks very much.
Are there any questions around in the room? Okay.
I was just curious, you had mentioned at the beginning every hour all your jobs are deployed. So is that the trigger between the tests, there's a latest tag or whatever, and at once an hour, that is what is deployed?
Every hour, the released version of taps runs. That runs every hour. The pipeline I just showed you is when there's a new commit to master, meaning we've changed the taps code. We've refactored it or added some functionality. Does that answer your question? Yes. Any other questions?
Any other questions? There was one around here, right?
I was just going to ask about the automated tests. Can you give us an indication of what do the automated tests actually do? So are they performance, are they functional type tests?
They're
and how many are they?
They are a combination of unit tests of the taps code itself, integration tests, which verify that there's a number of different ones, but some of the ones are that the branches conform to a certain regex pattern, for example, that people create. Sometimes they don't follow naming conventions. There are parsings, as I mentioned, of Kubernetes build YAML files. There are parsings of the pipeline scripts themselves. There are at least 6 or 8 different kinds of tests. Is that okay?
Okay, more questions around the room? Yep.
I think on one of the earlier slides it mentioned you run like a firmware job seed to generate the Jenkins jobs.
Right.
So do you guys have like a test Jenkins instance where you can run it to make sure things are good, like when you make those
Yes.
changes, or how does that work?
Yes, when I say Jenkins test, I mean it's a completely separate instance.
Oh, okay.
Yes, absolutely.
So we still have more minutes, a couple more minutes for questions. Anybody else? No? Okay, so thank
All
you very
right,
much.
Thanks again. Thanks.
Let's get the next speaker in the room.